Alright, what's up? It's Quinn, and in this video, I'm going to talk about a new concept, I guess. I was talking about this on a plane ride with Ian Warshaw. We were talking about this concept, but it's sort of I guess you could call it key circle shapes. That's probably what I'm going to call it in the title of this video. Key circle shapes. So it's sort of drawing shapes in the key circle, like where each point of a shape is a like a note, like it corresponds with a note in the key circle, and each shape makes something different. So the first thing I was introduced to this concept, I saw a key circle in the background of somebody's video, and it had a square drawn on it, and I was like, what the heck is that? And like there were 3 squares, because there's 4 points in a square. There's 12 notes on a key circle. 4 times 3 is 12. So and you can do this with triangles too, because triangles have 3 points, and that's, well, I didn't know if you knew that or not. I just thought I'd tell you triangles have 3 points. But triangles have 3 points. That's a number that goes into 12. So you can do triangles, you can do squares, you can do single points, you can do lines, and you can do hexagons. I think that's the one with 6 sides, but whichever shape is the one with 6 sides. I didn't pay attention in geometry. Alright, so I'm going to start with, so single points would just be, a note in the key circle, one of the 12 notes. So like C, G, D. But what would lines be? So we draw a line, C to G flat, that's a tritone. Do it again, G to D flat, that's another tritone. So single lines make tritones. Oh shit. That one goes like that, that one goes like that. So there's 6 single lines. Disregard this one. So there's 6 single lines. That means there's 6 tritones. A single line makes tritones. And then there's 12 single points. So that means 12 notes in this system. 12-tone system. There are more notes, but for the sake of this, we're working in the 12-tone system right now. So there's 12 notes, key circle. So single points, 12. Lines would be dividing that 12 into 2, which is 6, and lines are tritones, so that means there's 6 tritones. And then the next highest would be triangles, so let's see if I can make a triangle without. So there's a triangle. So what does this make? G flat, B flat, and D. That's an augmented triad. So let's see how many of these there are. So there's another augmented triad, F, A, D flat. So it's 2 augmented triads so far. Now we have a C, E, A flat, which is or G sharp, technically. But so there's 3 augmented triads. And then you have one more. So that's 4 augmented triads in total. 6 tritones, 12 notes. So we can also do this with squares. Let's see what squares are. And later on in the video I'll talk about how you can actually apply this concept. So squares. There we go, square. What is this? So E, G, B flat, and D flat. That's a fully diminished 7th chord. So we're gonna have 4 squares, or we're gonna have 3 squares, because 4 times 3 is 12. So that means that there's only 3 fully diminished triads, or fully diminished 7th chords. That's because when you invert a fully diminished seventh chord, which means you're taking the bottom note and then putting it on the top, it just becomes another fully diminished seventh chord. It's not an inversion of the same fully diminished seventh chord, it just becomes a different one. Because you're stacking minor thirds. Fully diminished seventh chord is made of minor thirds. So when you take one of those take the root note and bring it to the top, it's still just a stack of minor thirds, which makes it a new fully diminished seventh chord. Alright, so let's do the next one. Alright, so that's A fully diminished, or C fully diminished, or E flat fully diminished, or G flat fully diminished. All the same thing. And then the last one, there you have it right there. There's only 3 fully diminished chords, and those would be represented as squares on the key circle. Alright, so now what's left? We've done 4 times 3, which is squares, 3 times 4, which is triangles, straight lines, which is just 2 times 6, and then single points, which is 12 times 1. We also have to do hexagons. Is that right? I don't even know if that's right. Hexagons. Yeah, that's right. Hexagons is the 6-sided shape. So what would hexagons be? Let's draw them out. So alright, there's your hexagon. So let's see what that would be. F, G, A. So far we're moving up in whole steps. A, B, D flat, E flat. So a hexagon makes a whole tone scale. And since 6 times 2 is 12, that means we have 2 whole tone scales. So there's your concept of key circle shapes. And the way you can apply this to actual music, there's no way. I'm just kidding. I haven't worked it out, but I don't see how you could apply this. This is sort of just a novelty that I found out while talking to Ian. But yeah, there you go. Shoutouts to Ian. Peace out. See you in the next video.